managed to get through that unscathed.
Mostly unscathed. Welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 212. We'll be staring through integrated circuits, reading Bloom filters, and repairing, reworking, and reballing. We had a big party this weekend, Hackaday Berlin, and it was also the kickoff for the 10th Hackaday Prize.
That's a big number, putting up double digits. Finally.
Big round number. I was like, How could that be? We had the first one in 2014, and I'm like counting on my fingers and toes, and I'm like, oh yeah, that is 10.
The world has changed a lot in 10 years.
Yeah, it has. When we were planning for this one, we did a little looking back at some of the old prize winners and stuff, and that was actually really fun. Really inspirational to go back and see what everybody has been up to since they got the prizes and what happened to the winners in the last 10 years. And the funny thing is almost all of them took the prize money, put it back into their project, and kept it going, which is pretty fun. From the very first one, which is SatNogs, a satellite network of ground stations, to the very last one. So pretty cool.
And nobody ever went to space, unfortunately, right?
Nobody went to space.
What was that, 16? No, 15.
Yeah, or it was 2014 even. That was the first one.
Was it? That was the first one?
Yeah.
Oh, right. Yeah, because it was SatNogs, yeah.
The very first one was go to space. And I wonder, how much did it end up costing? We've actually sent tourists to space now. How much was the bill on that?
Yeah, I don't know. Probably more than the prize.
The first few prizes were super hefty. We were putting like all the money into the first place and second place prizes and not much into, the lower tiers. And that first place prize was $200,000. But I still think that isn't enough to get you to space.
Yeah, probably not.
You could be William Shatner and I guess you'd get a discount.
I was going to say something about it cost by the pound, but I didn't. Then you threw the Shatner thing in there, and I didn't want to be unkind.
All of a sudden, that's a little gauche. Yeah,
and yet here I am being unkind.
Oops. Anyway. This also means that the Hackaday Prize is on. Not only is it the 10th one, but it's on right now. And the first challenge is re-engineering education, where we want you to just enter your educational projects. And this can mean either that the project itself helps you learn something, or it's a project that's designed to help people learn by making it. That's the kind of angle that I think we're going to get the most entries on, because everybody likes learning by doing, right?
I kind of sit on the Hackaday IO projects on a daily basis, and I'm already seeing stuff pour in. So people are getting going already, which is pretty amazing.
It's easy if you've already got a project in there. If you're thinking of entering, you should totally look into the rules and make sure that you don't need to create a new Hackaday IO project just to enter it in the prize. Because I think we had that as a rule in previous years that you had to have a new project. And the easiest way to fulfill that requirement is just to start up a new IO page. If you've got a project that's halfway done but not completely done yet, copy whatever over there, start with what you got, and then get the heck to work, because the prize is on. The challenge rounds this time, we picked them all to be kind of our favorites of the last 10 years. And so we did an education one, 4 years ago, 5 years ago. We did assistive tech 3 years ago. We did green hacks and all sorts of environmental stuff last year. The new category this year is gearing up, which is to build your own tools and tooling. So, if you're going to build your own oscilloscope so that you can use it, or if you're going to build your own measurement devices or your own XY stage for your microscope, I don't care what it is. If you are building tools that help you get your work done, it's good for the gearing up challenge. And then last but not least is wildcard. And this is, of course, the wildcard, where your projects can be whatever they want to be. We're not going to tell you what they have to be.
Wildcard's always fun, but more tools is more tools.
Yeah, I think that's going to be a really good one, actually. I'm
Yeah.
really looking forward to seeing what people come up with here, because this is the kind of thing we do all on a continual basis, right? Like, whether it's just making jigs in the wood shop or figuring out a janky way to heat plate solder things or. I mean, this is something we all love to do, so I think this one's going to be super exciting. But we also like to teach. We also like to help people. We also like to save the world. I mean, bah. I'm actually completely happy with the 5 rounds this year. This is kind of best of Hackaday Prize. So get your fingers moving.
This is a journey into sound.
What's that sound?
What's that sound?
And then that brings us to What's That Sound? Last week was a listen to the sound and guess week. This week is a draw a winner week. Have you listened to the sound yet, Dan?
No, I'm clicking my way there right now. Where's the wave? There's the wave. God, that's loud.
That's what, yeah. Christina played it before she was ready and was like, wah, and sat down.
The volume was all the way up. Ow.
Sorry about that.
That's an impact driver.
Correct. It's an impact driver. This was one that I figured a lot of people would get, and you all did not disappoint. It's an impact driver. In fact, so many people answered this one. I think we got 47 answers that I had to be a little bit picky about which answers I'm going to count as right. And in particular, a lot of people said it was like a drill with a clutch, which is partly right, but it's not really a drill. If you're using an impact wrench as a drill, we're going to have to talk. But even if you're the world's pickiest bastard, which I'm trying to be, we still had 26 correct answers for this one. So I think that's a good setup. And basically, all of the 26 correct answers said impact driver, and a lot of them mentioned the clutch sound at the end. And I guess it does sound like it's clutching at the end, huh?
It does. Now, did you record that yourself, or did you get that from somewhere?
I didn't. I found it on YouTube.
I
snipped it out of some demo where a dude was doing impact drivers. So yeah, correct answers are all very correct. And so some of the wrong ones are also very almost correct. Air impact wrench tightening a lug nut, possibly on the passenger side front wheel of a 2005 Saab 9.3. Possibly.
Strangely specific.
Judging from the pitch, it's a Bosch cordless drill in first gear. It wasn't. I think it was actually a DeWalt in the video. I can't remember, and I think someone else actually says that. So I think someone else mentions the brand, but there's no way you could possibly guess that. Justin, a cordless impact wrench tightening a bolt and giving it a few extra ugga-duggas.
Ugga-dugga.
It might have been driving a lag bolt or something. I'm not going to get too picky on this. So yeah, all the right answers were all the right answers. Congratulations to everyone. Let's pull up a random number. And to do so, I'm going to use the NIST's randomness beacon, which is a crazy random number generator they have that every minute, I think. Yeah, every 60,000 milliseconds. So every minute puts out a new random number. They're then kind of blockchained together, and that means it's unfalsifiable chain of random numbers. So you can verify that this random number is the one that it is. And I'm taking it and I'm moduloing it with the number of right answers we got. So let's see what we get here. And I'm going to have to write a script for this because this is such a fun way to get, if you're into that sort of thing.
Yeah, I guess so.
Which I am. And the number is 12. The guaranteed randomest random number is 12. I'll give you guys the time and date stamp for this so you can replicate 12 on your own to make sure I'm not cheating. And let's see, who is number 12? Impact driver Gooey Louie. That is G-U-I Louie. Gooey Louie. Congratulations, Gooey Louie. Glad you got this one. That's pretty sweet. Although, I wouldn't have been too sad if Turbo Ferret won. But you don't get to pick. You don't get to pick.
So your randomness beacon's got me thinking now. I think I want to build like a little pirate ham station that just transmits random numbers from the
Ooh,
NIST site. And just,
yeah.
I mean, it literally would be a number station, but have people try to figure out what it means.
But a number station broadcasting random numbers. That is, I think
Just to be
that's
mean.
I think I was gonna say I think that's actually really mean. I'm not gonna lie. All right, well let's start talking some hacks. I have a kind of a twofer of looking inside ICs this week, and I wanted to just cram them together. Start off with creating a Game Boy ROM from pictures. This is work done by Travis Goodspeed. Man, Travis is a longtime hardware hacker and kind of a brilliant security researcher. He runs the Proof of Concept or GTFO journal, all around good guy. In this, he is taking open a Game Boy ROM, and I think this is the boot ROM from it, and he etches off the top surface, takes a whole bunch of photos next to each other with a microscope, stitches them together. Because of the way this mask ROM is set up, it's basically got a layer of horizontal traces and a layer of vertical traces, and the numbers are stored by where you connect them up. And you can actually see this in the microscope. And so what's going on here is he's written some custom tooling to then find all the nodes, recognize whether they're on or off, and do this kind of auto-magically. There's a little bit of manual setup because your stitched together image won't necessarily be absolutely square to the grid. But once you get the gridding right, it then goes through and tries to figure out whether it's a 1 or a 0 just by looking at it real hard. And when it can't tell for sure, it actually tells you that it's ambiguous and lets you, go in manually and wiggle your grid lines around. But I think you hope that you don't have to do that too many times.
Yeah.
At the end of the day, this software and some other tools he uses, which include XOR-ROM, put all the values together and boom, he gets the binary ROM dump out of it just by looking at it through a microscope, that's actually kind of a pretty cool trick.
I'm looking at the lead picture here, and I'm trying to figure out which ones are ones and which ones are zeros. And I mean, I think I see the differences, obviously, but which one equates to 1 and which one equates to 0, I don't know. So it's kind of interesting that he's found an automated way to do this. Although, in the comments, a lot of it was geared toward why,
Yeah.
is this
Yeah.
this is a really hard way to go about this. And you
could just dump it if you needed to,
you could just dump it. But someone did come up with a valid, maybe more valid use case for this. Because this is a boot ROM, there's some stuff that you can't read in a boot ROM. It just won't dump. So This might be the only way that you can get something. Wouldn't be necessarily practical off of like a game cartridge or something like that you could just take the chip out and put it in a reader and read it. I mean, it would work, but it's a lot more work to do it this way.
Yeah.
But it's an impressive amount of work, and it's in developing the tool chain is a valuable skill that, that may come in handy at some point in the future. Got to respect that.
That's exactly right. I think if you're asking why Travis is doing something, you may not know yet why he's doing it, but you'll find out later. And there might be all sorts of mask ROMs out there with read protection on them that try to prevent you from doing what he's doing physically here.
Sure.
It may just be a finger exercise, who knows? Or his real target may be a chip that he's not telling you what it is. I don't know this for a fact, but
stay tuned for details.
Could well be. One of my other favorite hackers, Bunny Huang, has a demonstration peeking inside ICs with infrared. He's got an infrared microscope, and I'll be damned if that doesn't make the black casing on integrated circuits entirely transparent. It's the really coolest. You should really just watch that video because there's something fantastically cool about seeing the chip markings on top of the chip and then seeing through down into the die as if the whole thing were made out of glass. Apparently, you put the right wavelength of infrared, 10, 15 nanometers on these things, and boom, you're looking straight down through the metal. And that's really cool for all those cases where you don't want to deal with all of the horrible etching things that you might have to do, which can, it can screw up, it can eat the metal layers underneath. If you're using hydrofluoric, it can eat your bones and then you'll die. I mean, there's all sorts of nastiness in decapping chips. And this is just like in situ, oh yeah, look, I'm looking straight into this thing.
I actually thought this one at first was more like a transmissive IR, so you were looking at the heat signatures coming off the inside of the chips rather than, shining UV or IR light on them and looking reflectively at it.
Right.
Although, now that I think about it, it'd be kind of cool if you could somehow image based on the heat coming out of the inside of a circuit. I think it would be pretty low resolution given most of the, like FLIR cameras and all the thermal cameras that we use for, like searching for hotspots and electrical panels and stuff like that. There's just not a lot of resolution there. So this is probably way more resolution, but still you might get some interesting information from the transmissive side too.
And in case you're saying to yourself, but Bunny, I don't have an infrared inspection microscope.
Oh, yes,
His second video linked here is him peeling the infrared filter off of a regular bone stock USB inspection microscope and using that. No excuse there. If it's got a CCD sensor on it, you just hop in, peel off the infrared filter. I don't know if he actually added another filter to try to block the visible on this or not. You could also do that if you weren't getting enough contrast, of course. You could add in a thin black piece of plastic to filter out everything but the infrared. I'm actually trying to sneak through and see if he does that. I think he actually doesn't. I think he basically just does it in a dark enough situation and then just hammers it with the infrared so that that's basically all that's getting back to the sensor. So this is a really super cool looking effect, and it's one you could pull off yourself with a bunch of infrared, really bright infrared LEDs and a camera microscope that you're willing to sacrifice to the cause. So kudos. I had no idea.
This kind of the quality of the images sort of reminds me of Shahryar's over at the Signal Path. Shahryar's X-ray vision. That he whips out his X-ray microscope from time to time to show you the inside of circuits. And this is probably multiple orders of magnitude cheaper than the stuff that he has on his bench.
What I've learned from this one is that I want to get a cheap digital camera, open it up, peel off the IR sensor, and just point it into my microscope and see what I get. Like, you could duplicate this on the dirt cheap if you already have a microscope. Now I'm going to have to. That's just so cool. Anyway, have a look at these two. Travis's involves, decapping the chip the old-fashioned way, but then doing the cool analysis. Bunny's bypasses the chip decapping. Imagine putting those two together and analyzing, mask ROMs without even bothering to decap the chips. That would be a whole world of convenience.
All right, first up for me is Clever Mechanism powers this all-mechanical filament respooler. I spotted this one from Miklos Kizeli, and I'm not even sure if I'm pronouncing that correctly, so apologies if not. But this one goes to the simplicity is the best rule for design sometimes. What's a filament respooler? I mean, it's pretty self-explanatory. If you have FDM printer filament that you want to get from one spool to another, you would probably not want to wind it by hand. That would be a mess and a pain. So come up with a mechanism to do that. Now, first thing you might think of is, okay, well, I'll get a spool and I'll get a stepper motor or, just a gear motor or something like that rotates the take-up spool, and I'll have a feed spool, and then I'll have some sort of mechanism for kind of indexing the filament across so it doesn't all end up on one place on the spool and you get a nice even wind. Maybe that's a stepper motor and some gears or a servo or something that translates the filament back and forth. Nope, not Miklos. He decided he's going to do this all mechanical. So it's all 3D printed. Well, except for the bearings and stuff like that. And the gear train that he came up with alone is worth the price of admission, with these herringbone gears and hand crank to power the take-up. I should mention, actually, the whole point of this thing was some filament is coming shipped on cardboard spools for environmental purposes. There's a lot of waste plastic with your standard plastic reels. Putting them on cardboard that's recyclable, that seems like a decent idea, except for the fact that sometimes the cardboard starts breaking down after multiple uses, or after long use, and you get some fibers that are going to stick to the filament, and then that causes problems with either an extruder or other points in the feed mechanism for the filament. So maybe you want to get your filament on cardboard spools, but then transfer it to a plastic spool, which would be neater and cleaner for actual printing. So anyway, so the drivetrain also powers this very, very clever sector and rack and pinion mechanism that perfectly synchronizes with the rotation of the spool and moves the filament across the width of the spool as it's winding it on there. So you always end up with the perfect one filament layer as you go across the spool, and you wind on whatever 500 grams a kilo of filament. It goes super fast. In fact, you could probably make this go a little too fast and end up when you come to the end of the spool, you could make a real mess. But I just thought the whole mechanism of the translation bit of it was so fascinating, and you really got to take a look at it and watch the video. The video in here is actually by somebody else entirely, Brian Vines from the BV3D YouTube channel. He kind of, goes over what this thing is about and how it works. It gives a good demonstration of exactly what it's capable of. Does everybody need a filament respooler? Probably not. But at least you have to take a look at the mechanism so you can keep it in mind for some other purpose that you might have, some other use case that it could be good for, because it really is super clever as opposed to making it electrical or anything else.
That's actually a classic mechanism. It's got it's a rack and pinion kind of thing. It's so there's a circular gear and then there's two straight gears, right? Racks. They're regular teeth on them and they're on either side of it. And the gear only has teeth on half of the circle. And so it goes turning and it engages with the lower rack when it's going one way, and then it spins around and it engages with the top rack and pushes it back, and then it spins around and engages with the lower one and goes back and forth. It's a deceptively simple, absolutely brilliant mechanism. Yeah, when you need rotational turned into oscillating motion, hot diggity.
Yeah, the thing that gets me about it, though, is the math involved here, because he's got what I'm looking at, like three gears in the power takeoff part. Then he's got a worm gear that drives the sector gear. The sector gear has to have the right number of teeth and it has to engage at just the right spot. So there was some thinking.
And there's some worm gear in there driving the little thing that's turning, and it's got to be. Yeah, but it's all just multiplying numbers together. It's all just fractions, yo.
Yeah, no, nobody ever had problems with fractions.
It's just a very pretty, geary machine, and I don't think you need any excuse to make a pretty, geary machine.
Satisfyingly geary.
All right, well, this is going to unsatisfy you. If that was satisfying... If you're the kind of person who likes gears, you're going to hate this next hack. This is Bus Stop Bloom Filter by Julian. This is actually really clever, and I think it's cleverer than some of the people in the comments gave it credit for. The idea of a bloom filter is it gives you a simple way to figure out if some element you've got is in a bigger set. And that's kind of this abstract mathematical idea. The problem Julian is applying it to here is to figuring out if your stop is on the route of a given bus that's going in a given direction. So imagine you end up at a train station or a bus station. Trains going this way and there's trains going that way, and there's 4 different lines sharing the same rails, and a train comes up and you're like, is this train going to go where I want to go? And all it says on the train is it says it's the U5 and it says it's going to Potsdam. And you're like, but I'm not going to Potsdam. I'm going to some place that's on the way from here to Potsdam. Is this train going to go where I need it to go? You just want to look up, does it go to the botanical garden? So that's what the Bloom filter solution here gives you. And Julian's set it up so that it's got a nice kind of graphical representation where like it's got, red bars and black bars and dots and, a bunch of other kind of signals. Instead of having to match whether it's got ones and zeros, it's got, a colorful pattern. So if you know the colorful pattern of your stop, you can then look at the sign on this train and see if your pattern is in the bigger, more confusing pattern that's on the train. And if it is, it's going to your stop. And that's actually really awesome because it encodes kind of all of the stops that the train's going to go to and makes it really easy for you to do the lookup because you just have to look at your particular set of codes and say, is it in this funny pattern? And that's what the Bloom filter does here. I actually went and did my deep dive into the maths of Bloom filter, so I'll throw 2 good links for you here. A Bloom filter basically works by being a lot of different hash functions. If you know what hash functions are, you can take like MD5 or something. You take like a really big file and then you run it through this function that gives you a hopefully mostly unique 256-bit number out of it. What you're doing here is you're using a whole bunch of different hash functions, and then, which means you get a whole bunch of different numbers corresponding to your bus stop or the document in question. And then you take those all modulo some other shorter number, and I think here he's using like 192 signals. Set all those bits. And so if the bits you get out of it are, bit number 1, 4, and 7, you set those. And then when you enter another bus stop or book or whatever into your filter, you run these hashes again and you set those equivalent bits. And you just keep doing this. And you never turn the bits off. And this is what's weird about the Bloom filter. And this is what gives it its particular character, is that when you have the bus stop you want to go to and you do the same hashes on that and you look it up there, if the same bits are all set, you know with pretty good probability that your bus stop is in that list. But it could also have been the case that 2 different bus stops, when you or their bits together, gives you the bits that would have corresponded to the one you're looking for. The upshot of this is that you can tell absolutely certainly with a Bloom filter if your bus stop isn't on the right path, but you can tell only with probabilistic certainty that your bus stop is on the list if you're looking at it and you see it there. And that's because there could have been a collision of 2 other bus stops that just happened to mask your bus stop, and so you'd see it even if it wasn't there. The idea is then you pick a long enough string here so that those clashes and random overwrites are extremely unlikely. Julian's doing that here, and he says he's got it down to 0.1% or something like that. You would want to drive that pretty low, because if you go up to the bus stop sign and you're like, does this go to my spot? And it says yes, and you happen to be on the wrong side of the probabilities, you're going to be very sad. So that's the sense in which this is kind of a weird application of a Bloom filter. It's almost never the case that you go up to a bus and you're like, does this bus not go to my stop? Which is what it gives you the answer to with certainty.
I'm not going to lie. This one baffled me.
I like probabilities. Anyway, I think it actually is kind of clever, and I think it's a neat way to have the idea of a simple representation for like all the stops on a bus map, right? On the other hand, you can just go look at the route map on the wall and see if yours is in the right place. So it may be a solution where there isn't a problem, but
I guess my other problem is I just don't have any context for buses. I mean, it's just the last time I rode a bus was probably 1984 or something like that. So,
yeah. Well, fair enough.
In other ways to fight climate change news, who needs gasoline when you've got sodium? Yeah, this is a little cringy in some ways. This is from, as Dave Roundtree describes him, YouTuber and serial debunker Thunderfoot. He's basically proposing using sodium, liquid sodium metal, as an alternative fuel for internal combustion engines. I mean, that's kind of the take-home message of this 30-minute or so video. Right off the top of your head, you got to think that's kind of crazy, especially coming from a guy who spends most of his time debunking stuff, other alternative energy projects and stuff like that. You figure, well, I mean, what's he got going on here? And for anybody who's seen sodium do its thing, when you take sodium metal and you throw it in water, it's fairly energetic. I remember a friend in high school, his father worked as a chemist in an environmental remediation company, and he decided to remediate some extra sodium metal that he had by standing on a bridge and throwing it into the Naugatuck River in Connecticut.
Oh, Jesus.
So that was interesting. So, and that's kind of what got me thinking about this one, because it's extremely energetic. Just YouTube, Google sodium and water, and you'll see some pretty spectacular ones. Potassium is actually a little bit more energetic. But basically what he's proposing here is to use sodium in an internal combustion engine. Will it actually go through the injectors? Can it be used as a fuel? The end product of the combustion of sodium is sodium hydroxide. You take the little bit of the hydrogen and oxygen from the water, you mix it with the sodium, you get a lot of sodium hydroxide, which is why those thick white plumes that you see in all those sodium exploding videos is there, and it's something you really don't want to breathe. The point here is that sodium has a very low melting point for, compared to most metals, about 100 degrees Celsius. To make this a little bit more manageable for his experiments, Thunderfoot mixed sodium and potassium together in a sort of a eutectic mix that stays liquid at more or less room temperature. He actually managed to get it spraying out of Ford Festiva fuel injector. Yeah, okay, it could be used as a fuel. The idea would be that the sodium hydroxide that results would go into the atmosphere rather than the carbon dioxide and reflect sunlight back out into space, so it would have a cooling effect. I don't know if I like that idea so much. I mean, if you really wanted to do this, what I thought of when I first saw this video was, why not just use sulfur? Sulfur is liquid at a relatively low temperature, not as low as sodium or potassium, but it's still, you could probably manage to have a liquid sulfur engine. But the product of combustion, therefore, would be sulfur dioxide. Sulfur dioxide aerosols come out of volcanoes, and when they get ejected into the stratosphere, you've got global cooling. We saw that Mount Pinatubo and whatever that was, 1980 something, 1990, I forget. But it lowered global temperatures by a measurable amount for a couple of years after that eruption, and that really wasn't that big an eruption. So imagine if you've got all these internal combustion cars going around with liquid sulfur in their fuel tanks and burning liquid sulfur and barfing out clouds of sulfur dioxide. What could go wrong?
Smells good.
Yeah, what could possibly go wrong? Yeah, it's a little weird, but
crazy.
At least there's some alternative thinking going on here. Let's say that.
Yeah, I think I'm totally with the skeptics in the comment section who are like, wait, the byproducts of this are lye. So you're going to be putting out, sodium hydroxide, lye everywhere. And you guys are missing the point. The other one is what happens to those extra pair of hydrogens. And the answer is they get together and they make hydrogen gas. So the other thing coming out of this is, of course, hydrogen gas. I guess he's probably going to burn the hydrogen too, but does that want to happen at the same time? I don't know. My experience, like yours, with dropping sodium metal in water is that the hydrogen gas gets given off pretty quickly. The reaction is super exothermic and it makes a bunch of heat. And if you're lucky, you get a hydrogen gas fireball out of it too, in addition to like hot lye water spraying everywhere. It's just really, it's drop the chunk in and run for your life, son. It is not a very good I mean, you could get away with it, but you got to be careful. The other question then is how how you recreate it, how you make more of the sodium metal in the first place. How easy is it to like refine sodium metal? Because I think the directions we're moving toward in new cars is not to have the fuel be a fuel, but to have the fuel be a store of energy, right? So we have some kind of bigger cyclical system. We find a green way to produce hydrogen. We put the hydrogen in the car, we burn the hydrogen, or we find a green way to generate electricity. We put that into battery, and then battery gives it back to you later. Like the fuels in kind of the ideal case situation here are going to be more like stores of energy, more like batteries in a way, than like we're digging up gas out of the ground and just running it. So I guess I'm wondering, how easy is it to make sodium metal if you've got a bunch of lye kicking around contaminating your water?
One of the comments was, oh yeah, I've got a whole bunch of sodium metal sitting around all the time, I can, and it just happens to be liquid. I can put it in my tank, Like, no, that's not the way it really goes. And that's what got me thinking about sulfur. It's like, wow, sulfur, that's super, super common. There's mountains of sulfur that you can have and you can melt and you can use as fuel. And that's right. Sulfur comes from the ground when you are making, or when you're harvesting oil from, fossil sources. So like, oh well, so much for that.
Good for Thunderfoot. I do like to see sodium metal exploding in water, but
yeah, I'll take that all day. Yeah.
But I'm not sure this is going to revolutionize the automotive industry. All right, my last hack for the day is something I had no idea existed. Kino Wheels gives you a hand learning camera operation. This is an open source project made by a company, CAD Rage, that looks like it makes an app for cell phones that lets you, line up your shots and figure out how you want to frame them and help you with video and filming pre-production. In that vein, what they've got is a two-wheeled, and by wheels, I mean these are like hand crank wheels of a particularly snazzy looking kind, controller that then turns some encoders on the inside, and it's got nice bearings and et cetera, and is basically then a peripheral that runs a camera dolly rig inside an Unreal Engine virtual environment. Why would you want to do this? Well, if you're going to be a dolly rig operator, you have to practice your like pan and tracking shots. And one of these wheels controls the way the camera on the tripod turns kind of horizontally, and the other the way it goes vertically. And so if you want to do one of these shots where it goes from, an upstairs window and then it follows the woman walking on the street as she goes around the corner, you have to coordinate then this movement, up and down and over and all of that at the same time. That's what this thing is giving you practice for. It's a practice remote camera operation rig. And I just thought that was so crazy because it's not a problem I suffer from at all, not being able to run my camera rig. But if I did, this would be the awesomest practice thing ever. And because this thing is open, a bunch of people have written their own software for it so that you don't necessarily have to use CAD Rages. Right now, I think they only have it running on Windows, and some people are wanting it to run on other things. My guess is it's a simple matter of flashing the Uno that's inside the box, because the hardware here is two of these really fancy wheels so that it has the right feel so that you can practice it, and some rotational encoders and some bearing blocks on the inside. So you could have it output whatever you want, however you want, and that's kind of fun. I kind of want to make one of these with these like super big fancy wheels as a jogging thing for my CNC router. That would be awesome.
The eye-opener for me here is that there's a DIN standard for spoked hand wheels.
Well, yeah. How could there not be?
I guess I just wasn't thinking. But you say that, that the market is limited for this because, how many people are going to want to operate cameras? That's true. But it's getting less true as time goes on because Hollywood production of professional grade media was always really a specialized thing. You went to Hollywood, you went to New York, you learned the trade, you joined a union if you were on that end of things, you joined a guild if you were on the other end, and you kind of, learned by doing, and there was a very small community that did these things, especially the super duper stuff like Steadicam operators. I mean, I wanted to be a Steadicam operator once back in the day. I was like, I saw a Steadicam rig and I thought, wow, that just looks so cool. I want to do that. So I kind of looked into this, and it's a very small community and it's very difficult to get in. Not so much anymore. Almost everybody's a filmmaker now.
Right.
You can buy damn near pro quality gear that gives you really, really good quality output with an iPhone on the top as the business end, and you have to then figure out how to move this thing in 3-dimensional space and get the shot that you want to get. So yeah, I mean, it used to be that that camera operators was a fairly limited fraternity of operators, but now it's getting more and more people are getting closer and closer to that.
My first quick hack this week is robot 3D prints giant metal parts with induction heat. We haven't seen any actual work by this company. The image is a render, but there's a company called Rosotics that's claiming to make a big induction heated 3D metal printer. And I guess I just like the idea of using an induction heater at the hot end to see if you can melt the metal as you're squeezing it out. It makes it kind of the most analogous to the plastic ones I've got in my office here, only for metal. Still haven't seen any proof of concept from them, but maybe it's something a hacker could do. Next up, long distance gaming over packet radio, Glass TTY, aka G6 AML. This is a ham radio hack in which packet radio, that is, kind of internet packets over normal ham radio, is sent to and from a Mac computer and a PDP-11 so that he can remotely play the Cave Adventure game over ham radio. How lovely is that? And last up, Magic 8 Ball provides tech support by Cody. It is a Magic 8 Ball that tells you to try turning it on and off again, or it gives you a 404 error. It's witty and humorous, but it makes nice use of one of those round OLED screens and a microcontroller and an accelerometer, and you're done. Wedge that inside a Magic 8 Ball, and you can make it say whatever you want, not just witty IT things.
Okay, first on the quick hacks tour for me, Ondal, Korean underfloor heating. I had no idea how complicated they were. I thought these were sort of like the Roman hypocaust, and I guess they kind of are, but the serpentine pattern of channels and brickwork that goes into making this indirect heating method is just amazing. You got to check the video out. It's in Korean, but it's worth watching because of the craftsmanship and dealing with variability and all this stuff. You'll love it. Next up, enormous metal sculpture becomes an antenna. This is out of the Rochester Institute of Technology, where they've got this 70-foot tall bronze and steel statue sitting in a courtyard. And it's another one of these will it antenna things. And spoiler alert, yes, it will antenna. They hooked it up to a Yaesu radio, a 5-watt transmitter, and they managed 20-meter band contacts all over the eastern United States. It was kind of done as a joke, but it will antenna. And finally, the Keychain 6809. This is a beautiful little 5 by 5 centimeter keychain sized project that is a complete working 6809 computer. Level of integration here is beautiful. The way everything fits on the board is amazing, especially considering you've got to use these big double dip for the chips for the CPU and the ROM. Everything else is sort of surface mount and underneath and wedged here and tucked there to kind of get everything to fit on the board, but it all does, and it looks great, and it actually works.
All right, and that brings us to our Can't Miss articles, long-form pieces written by our fantastic Hackaday writing staff. This week, I'm going to start off with Maya Pasha's Europe's Proposed Right to Repair Law, a Game Changer or Business as Usual? And when it has a question in it, oh no, it's a binary question. You can't just say yes or no. In fact, I think that may be like, this is Elliot's law of headlines. If it's a binary choice question like this, you're like, I don't know, maybe. And I think that's where I'm stuck on this. Probably a little of both. The law in question, at least as it's framed right now, it's not fully in place, is going to make sure sellers repair things, or at least offer repair services, make sure that you can get spare parts for things. They're going to increase the mandatory time that spare parts have to be available for devices. What you should be able to get full information about how to do the repair if you need to, et cetera, et cetera. It's actually a pretty nice looking set of requirements. The problems are, I think, how this is going to be enforced at all. Like, I think a lot of people got into this in the comments. Some of the design changes that will need to be integrated into new washing machines or new cell phones or new fridges to meet these demands are actually going to be troublesome. They're going to have to happen way upstream of the sale. I don't know how much passing a law like this is going to be able to change things like that or push it up. But it's also kind of putting pressure in the right direction. And I think that is making sure that stuff we buy is more repairable so we don't end up throwing so much stuff away. And I do like that idea of it. The other problems that I can see with this, of course, are the manufacturers can try to jigger things by making the replacement parts so expensive that you're not going to want to replace it. You're going to want to buy a new one. But then maybe that's okay, right? Like, if their problem with forced obsolescence is that they get so much money by fooling you into buying a new one and throwing the old one away, isn't it just as good if they get that same money by giving you spare parts that fix the thing and prevent you from throwing it away? So, maybe I guess I feel okay about that. And another comment that I thought was really insightful was, how does the end user know? Like, how do you know which one of these dryers is more reparable than the other one? That, I think, is actually really interesting and points to something missing from this regulation, which is kind of this is a regulatory requirements type thing. But the other way you could think of going is to make repairability labels and mandatory repairability labeling on things and just let the market handle it, right? Like, people who want repairable dishwashers buy repairable dishwashers, and people who want to pitch them out and buy a new one get to buy the cheaper ones with which they could do that. So maybe that's kind of another way to go. We'll have to see, right? Like, I can just imagine being the government board who's like decides whether this is a repairable device or not. Phew. That's going to be gray lines and difficult classifications left, right, and center.
I mean, we talk about right to repair and the irreparability of all modern whatever, phones, cars, TVs, blah, 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 and all that stuff. They're not built to be repaired, and they're built to be replaced. First of all, that's not true. We see that all the time. We see these repairs done all the time on Hackaday. Someone takes a non-repairable whatever and manages to figure out what the problem is and fixes it with a $2 part or something like that. We see that all the time. And that's always been the case as devices have gotten more complex, and I'm not arguing that they haven't. People have kept up with that. I mean, it wasn't that long ago when PC boards were populated with dips, and it was easy to see a resistor that had blown up or a capacitor that is leaking or something like that, and you could replace that. It was easy to do. It's still possible to do it. It's just not as easy as it was before. And there's still a population that's willing to do that and willing to learn and tool up and get all that stuff. I mean, and go the other way. Go back to the beginning of the Industrial Revolution. You had to go to the village blacksmith if you wanted a tool fabricated in the first place. Or if your gun didn't work, you had to take it to the gunsmith, who was probably the blacksmith too, because you didn't have the specialized tool and the specialized knowledge to do that at home. This has been going on for 200 years or more in one way or another. There's always going to be a population of people who don't want to do it. These people showed up in the comments for this one. It's not worth my time to do that. I'll just buy a new one, blah, blah, blah. We're still going to see them showing up in our space here because for some people, it isn't worth the time or effort because they've got other things to do. Sometimes I think that's a false economy, but that's their problem, not mine. I'm always going to want to fix it myself, or at least have a first crack at it, right to repair is, I'm glad these efforts are out there. I just don't know that it's going to, like you said, be enforceable. And I don't know that it's going to maybe have unintended consequences. Maybe they're going to have to step back complexity of devices in order to comply with something like this, that, okay, well, here's all your, through hole stuff instead of surface mount because it's easier to solder or desolder or whatever, then maybe we're taking a step backwards technologically. Tubes were easy to fix, tube circuits.
Oh God.
Take all the tubes out and take it down to the drugstore and plug it into the tube tester and buy the tube that was broken. So are we going there?
Yeah, you're right. And I think it's worth playing the devil's advocate and saying, what's the cost of right to repair? Because like you, I'm so into it that I'm like, yeah, right to repair, go, go, go. But it probably would make things more expensive. It probably will make some things anyway larger, just because of design for reparability rather than, design for smallest and most glued together. So yeah, you're probably right. There probably are all sorts of trade-offs that we're actually making here. It's a win for me, but if someone else doesn't care about repairing it and then all the devices got a little bit more expensive, it's putting a repair tax on the people who don't want to repair stuff. Now, if you look at landfills and realize that they cost something, maybe this is the right way to put a tax on people. And, you could certainly make that argument, I think. But yeah, it's definitely not all win, right? Like you're definitely making trade-offs here, and it might be forcing designers to make things, bigger, less sexy. They're going to have 5 PCBs inside the dishwasher instead of one monolithic PCB so that you can replace them, something like that, right?
Yeah, and on the other hand, and this is another one of those cases where you need a one-handed economist, right? Because there's always on the other hand, maybe something like this spurs an industry. I mean, it's an industry that's already out there. There are repair shops, so you can, go to the cell phone repair shop and take your device in for repair. And maybe this doesn't stimulate average Joe to undertake a repair, like you used to be able to wiggle the tubes in your TV and find out which one was bad. Maybe it grows an industry of mom and pop repair shops that pop up to support this because it's a little easier, a little more approachable to repair these devices. And for them, it's worth having the specialized tools because they're going to make money back on it, with every repair, and they can amortize that expense for that tool over a bunch of repairs. So maybe you're stimulating a different industry, a new industry that'll grow up.
I'm sold. I hope that's the case. That sounds great to me.
I'd open one of those.
Yeah, right? I think the point here is that, of course, I think it's still way early days on this legislation. I think it's remains to be seen is where we have to say. But I do think it's awesome that we see kind of right to repair stuff in the States and right to repair stuff in Europe all kind of moving in what I think of as the right direction at the same time. And we'll see. It may be that there's kind of a global movement toward throwing less of our machines away and making them work again. At least it's a move in the right direction. We'll see how far it's able to go.
And speaking of repair, on a related subject, my choice this week is working with BGAs, soldering, reballing, and rework. This is more nuts and bolts, but it's very much in the ballpark of what we're talking about because so many devices have so many high density components in them, and ball grid arrays may very well appear in something that you want to repair, and you need to know what you're doing. Now, this is the second, I think, in a series of articles on BGAs that Robin has done. First one just sort of explored what it's like to design for BGAs. This one is more of the hands-on stuff on how you solder and desolder BGA components. I've kind of gotten into SMD soldering a lot more since the 2019 Super Conference when I did the Surface Mount Challenge. And I was surprised. I had never worked with surface mount technology before, and I managed to get down to, I don't know what it was, like the third sized LED down, and before I crapped out. But to be able to do that with a completely non-optimized setup with a janky soldering iron and a little head mounted magnifier and absolutely no experience at all, I was pretty impressed that I was able to do that. And I thought, well, hey, maybe this is something I can get good at. Turns out, no, I can't get good at it.
Oh, no.
Despite my best efforts and a microscope that I bought. It's not that I'm not capable of it. It's just that I haven't put in enough time and practice to get good at it. And looking at this article gives me a little bit more confidence or maybe a little impetus to up my game a bit. Like I said, this is very much a nuts and bolts piece to talk about the tools of the trade, as one of the headings is in this article. I'm surprised that Robin recommends a hot plate as much as he does. And thinking about it, I realized there's an article I'll put in the show notes. I did a rookie takes on an SMD repair, and I tried to repair my son's Xbox. The retimer chip, the HDMI retimer chip, crapped out, and I've been trying to replace it for the better part of the last 2 years, on and off. And always failing because I'm just not transferring enough heat to this chip. Now, it's not a BGA chip, but it does have a big heat pad or a heat transfer pad underneath that gets soldered in an inaccessible way like the balls on a BGA chip do. And maybe preheating the board would help me because I'm just not getting enough heat in. And that's basically what he's saying here is you can either use a hot plate as a reflow tool for an entire board if you're going to do a fresh solder job and you're just going to place a bunch of components and flow them down or reflow them down, or you can use it to in addition to a hot air rework tool, which is a clever idea. And you could just kind of, get the board most of the way there to melting and then use the hot air to finish it off, basically, and do one component at a time. I don't know. It's a whole world that I haven't opened up yet, but Robin's article gives me the feeling that maybe I should get into this.
Yeah, I think his advice at the top is spot on. If there's two teams, if there's team hot plate versus team hot air, I am definitely team hot plate. And he recommends that as the starter too. If you're only going to have one of these two tools, get yourself a hot plate. And actually that one he has, I had a chance to use one of those at a friend's place fairly recently. It's a damn nice hot plate. Like, that's the one to get. The one he has pictured here and or like the million different clones of it is the one to get because it's a good size. Big enough that you can do whatever the heck you want on it. And that is saying something. So my problem with hot air is I always end up using too much air and things end up flying. And I know I'm doing it wrong, but I'm never doing it wrong with a hot plate. With a hot plate, I just put it on there, I crank the temperature up, and it goes, and everything's happy. So yeah, I was also, like you, totally stoked to see the balling jig and to see that that's even possible and that there's this array of tiny, tiny little holes. Of course you can buy one. How could you not, right? And so you just line all the little balls up, heat it up, they stick, and then off you go. It's pretty crazy. I love surface mount stuff. I wouldn't do through hole except when I have to because basically I hate drilling holes and I like making my own printed circuit boards. So, that is a lot easier for my flow to just do everything on the surface. And so yippee. But reballing BGAs, oof. Just stepping back from the particulars here, I have to say this is one of those just fantastic Hackaday articles that you will not find anywhere else. It's Robin's got experience with this, and this is him sharing it with us. And it's slightly esoteric experience, but it's also something that if you wanted to get into doing yourself, A, you could, and B, it would be super nice to have the kind of helping hand of someone who's done it before show you the way. And that's exactly the spirit of this article. And man, it's just such a Hackaday article. I love it. And that wraps it up for this week's Hackaday podcast. Thanks tons for listening. If you want to follow the links or leave a comment, head over to the show notes, hackaday.com/podcast. If you see anything cool or do anything cool, shoot us an email at the tips line, tips@hackaday.com. And until next week,
keep on hacking.
Oh no, I'm saving it as a WAV file. Welcome to the Hackaday Prize.
Alrighty. At least I got that going for me.
Oh, hell yeah.
Hell yeah.
That worked. Sweet. You got it. One of the last... some people are ballers, and some people are reballers. I have to say, Robin is a reballer. I hope that's not offensive.